And the notes should be, okay. 4.7. Now, before we get going here, please, the words that I'm going to use for some of this stuff, don't let that freak you out or scare you, because sometimes people, again, kind of like yesterday, they let the wording of things throw them off. Okay, so what we have to do today, especially like what you need to find, is very simple, putting it into the right spots. That's the part that can be a little more difficult. This is called or pronounced arithmetic sequences. Okay, I know it says arithmetic, but it's arithmetic sequences. All they are, an arithmetic sequence is a list of numbers with a pattern of adding or subtracting to find the next value. That's all it is. A list of numbers, there's a pattern, the pattern is going to be adding or subtracting. That number that you add or subtract by is called the common difference, and the variable d is always used to represent it. Okay, so kind of some fancy words for a simple thing. Okay, so the first couple things is just practicing that exact thing right there. So I have the first one is -9, -5, -1, 3, and 7. What is the pattern that you see there? We're adding 4, right. So this is adding 4 every time. Adding 4, adding 4. So I would say, I'm going to write this both ways. I can say my common difference is 4. Okay, or I could also say common difference is the variable d, right? So I could also say d equals 4. Okay, and you'll see, especially with the variable, you'll see that down kind of towards the bottom when we get to the equation part of it. Okay, but some of your assignment today for this is going to be just simply that. Here's a sequence. What's the common difference? Or here's a sequence. Is it arithmetic? Are we adding or subtracting? That's all we're concerned about. So if it's multiplying or dividing, then we'll just click the button that says it's not arithmetic, because we're not worried about that right now. We'll do that. That'll be like next semester. Okay. What about the second one? 5, 2, -1, -4, -7. Yeah. We're subtracting 3, right? Okay. So that one, same thing. I'm not even going to write it. I could say my common difference is -3, or my d value here is -3. So adding or subtracting, that's all we're going to be doing. Okay, so that'll be part of the assignment, will just be that. That'll go quick. Or they might even ask you to say, what's the next 3 numbers of the sequence? The second part is where it might get a little tricky, where we are going to write an equation for the sequences. There's 2 ways to do it. They're called recursive or explicit. Okay, recursive or explicit. This like right here that I'm zooming in on, this is the recursive formula. And then this guy over here is the explicit formula. Okay, and on the assignment, they'll say a lot of times the recursive rule or the explicit rule. Especially this one, though. This one always throws people off. Okay, and you could probably figure out why. Okay, of that the n, and that n minus 1, and then that 1 down there that they look like they're exponents, but they're on the bottom, right? Okay, so they're not exponents that are on the bottom of the variable. They are just a part of it. They're subscripts is what they are. So like I would say that is a of n. This is a of n minus 1. It's just one thing. Think of it as it's one thing. It's not 2 separate things, it's one thing. We're going to label all the parts, okay? So this, the variable d, that's the same as what we just talked about a second ago. That is the common difference. That's kind of the easier one. That's just the common difference. That looks like a normal variable that we've seen. The a of n, that part, okay, that represents any term of the sequence. And just to be sure, like when I say term, because I'm going to use that word from now on over and over again, when I say a term of the sequence, do you guys know what I'm talking about? Not really. That's fine. So like down here, like we're going to use this sequence down there that I just zoomed out to see here in a second. But that right there, the terms of the sequence are just the numbers. The terms of the sequence are the numbers of the sequence. So I have -3, -1, 1, 3, and 5. Those are the first 5 terms of the sequence. Okay, that's all that means. All right, a of n minus 1. Okay, so a of n means any term of the sequence. A of n minus 1 means the previous term. the term before that one. Okay, and even here too, like you might still be like, I don't even know, I'm still not sure what that means, but that's okay. Once we look at the example, hopefully it'll become a little bit more clear when we do a couple of them. Anybody think they know what A of 1 at the bottom there, what that stands for or what that would mean? So not an N, there's an actual number there, right? A of 1.
Number 1 in the sequence?
Yep, it's the first term. A of 1 means what's the first term of the sequence? A of 2 would mean the second term of the sequence. A of 3 would mean the third term of the sequence, so on and so forth. If it said 15, if it said A of 15, that means the 15th term. Okay, so let's take this recursive rule. We're going to use this sequence down here, and we're going to write it. So that sequence, -3, -1, 1, 3, 5, what is the common difference for that? We're adding 2. That right there, that is literally the only thing that you need to do, the only thing that you need to find before you go and fill out the recursive rule. Okay? So really for all of the problems, that's all we're really concerned about is what is that common difference. Okay, here we go. Here's how we write it. A of n equals A of n minus 1. I'm going to highlight both of these. These two things are always in your recursive rule, just like that. People all the time when we do these, or when I let them go on their own and we have the test on this stuff, they try to like put numbers into places that don't need to be in there. Okay? Think of that as a variable equals a variable. Just think of that. Now, the second part, or the last part says plus d. What am I going to put there? I'm going to put plus 2. And I also need to write A of 1 equals what? No. What? -3. A of 1 stands for the first term. What's the first term of my sequence? -3. This is it. That's my recursive rule. Okay, so to kind of put this maybe into hopefully a little bit simpler words a little bit. This is saying A of n equals A of n minus 1 plus 2. That means to find any term of the sequence is equal to the previous term plus 2. Okay, so like we have the first 5 terms of the sequence up here, right? How would I find the 6th term? Add 2 to what? 5, right? Or in other words, I would add 2 to find the 6th term of the sequence is equal to the previous term, which is 5, plus 2. Does that make sense? So to find the 6th term, I would take the 5th term, that's the n minus 1, and just add 2 to it. Okay, now, the reason we also need to list the first term is this. If I hid that sequence and we pretend we didn't know it, and this is all I had, this is what I had right here. Or, in fact, let's say if I took that out. And the only thing that I knew was that the sequence that I have is that the pattern is plus 2. That's what this tells me. This tells me that the pattern is I'm adding 2 every time. Would I know what the sequence is? I know that it's plus 2, but do I know what the numbers are? No, I don't know where it starts. That's why we have to list the first term. That's why we have to say A1 equals -3. Now I know I'm starting at -3, and I'm adding 2 every time. Okay? All right, here's another thing too. I'm going to tell you right now why I don't like recursive rules. I don't think they're very useful, and to be perfectly honest, I only teach them to you because I kind of have to. Okay, and they like to show up on the EOC at the end of the year as well. I just don't think they're very useful. Here's why. Does anyone know what this would mean if I would say, or if I would ask you to find A of 20? Anyone know think they know what that would mean? No, not quite. It means what is the 20th number in this sequence, right? I have the first 5 up there. What's the 20th number? So if I try to do that with this, with using what I wrote, I would say A of 20 equals I would put 20 in for n. What's 20 minus 1 though? 19. So equal to A of 19 plus 2. A of 20 is equal to the previous term, A of 19, plus 2, right? Does anyone know what the 19th term is? Off the top of your head? No, of course not, right? Anyone know what the 18th term is? Or the 17th, or the 16th, or the 15th, or the 14th? No, we don't know any of that. So that's why I don't like these. or these I don't think are as useful, is because if I want to find a different term of the sequence, I need to just list them all the way out, which does not seem to be a very smart way to do things, right? So if I were to find the 20th term, I would need to know all 19 terms before it. So I will not make you do that for this. MathXL will not make you do that for a recursive rule. You'll just have to write them. Okay, that's all we got to do. Now, on the other hand, the explicit rule, that one's better. Okay, and I'll show you why it's better here in a little bit. Okay, one of the reasons why it's better is the formula. It's just one thing. Okay, it's just one thing. And if you look at the formula real quick, it has a lot of the same parts, right? A of n equals a1 plus d. Now, it just has this n by itself. So I am going to label that. That is the number of term you want to find. And we'll do that here in the notes, like on this next problem. Okay, but otherwise it's a lot of the same parts. Just looks a little different. So it's the number of term you want to find. So this pattern, or this sequence, I mean, it's 12, 7, 2, negative 3, negative 8. What is the, anybody know what's the pattern here? What's the common difference? Close. We're subtracting 5 every time, right? Minus 5, minus 5, minus 5. Again, that's all I need to know. We're ready to write it. So a of n, or any term of the sequence, is equal to, what is a1 in this sequence? What's a of 1? What? 12. First term is 12. And then it says plus d. What's d?
Different.
Yeah, what? It's negative 5, right? So since it's a negative 5, I'm going to put minus 5. And then n minus 1. And I'm done. N is my variable that should be in there. Because that's the number of the term that I might want to find. But that's my equation. But that's it. It looks like a regular normal equation, right? We do not need to distribute or do anything like that. You can leave it just like that and you'll be good to go. Okay, MathXL will be the same way. Now I do want to warn you, everyone look at the screen here quick. I don't know why they do this, but on MathXL, if you were to look at an answer that they came up with for this, this is how they would write it. Don't write this down. They would write it like that. They put the common difference number on the end, which I think looks really weird. Because if I want to distribute, why would I never put the number on the backside, right? It's always in the front. Okay, so just be aware of that. You might see that on your assignment, but again, if you type it in like that, you're good. It's not going to count wrong. It'll count right. Okay, same question as the last one though. If I ask you to find a of 20 for this one, what do you think we would do? Nope, not quite. Cool? Yep. I'm just going to take 20 and plug it in for n. That's why I like the explicit rule a lot better than the recursive rule. Now, at this point, I just got to grab my calculator and work it out. So can someone do that real quick? And then that way, that'll tell us what that 20th term is. And again, type that whole thing in at once, just like that.
87.
Nope. Yeah, go ahead. Should be negative 83. That's why I like the explicit rule better. What's the 20th term? I can just plug 20 into my equation, grab my calculator, and work it out. I don't need to know anything else. I know that the 20th number in this sequence is going to be negative 83. And that you will need to do or have to do in your assignment. Like they'll ask you maybe write the equation, and then the second part will say, find a of 10 or a of 8 or a of 12, whatever. They'll give you something, okay? All right, so those are the two different kind of ways to write those sequences. I have one more I want to do with you guys. Okay, we're going to use this one same sequence for both. Okay, to try to get it in our brains a little bit better, but we'll see. So, first thing, or the only thing we got to find, negative 9, negative 5, 1, 3, and 7. What is the common difference in that sequence? Plus 4, good. Again, that's it. That's all I got to find. So for the explicit rule, and I'm going to zoom out so we can see it, so sorry if it's hard to see it from your sheet. The explicit rule is a of n equals what? Remember, we're using this up here, right? The explicit rule, this one that I'm highlighting. What is it? Negative 9, that's first term. Whoops. Negative 9. Then what? Plus 4, because that's a common difference, and then times n minus 1. And again, like I said, you don't need to distribute or worry about any of that stuff. You can leave it just like that. MathXL will count it right. When we do that on the review tomorrow, on the test, after that, same way. That'll be just fine. Okay, and then now for the recursive rule, remember this is kind of the weird looking one. It'll be a of n equals a of n minus 1. Remember, that's exactly how those always are going to look. Any term of the sequence is equal to the previous term, then what do I need to put? Plus 4, right. That's the common difference, is plus 4. If the common difference was minus 7, then I just would have put minus 7 instead. What's the other thing I need to write here yet, though? We're not done, right? What am I missing yet? Okay, but it's a of 1 equals negative 9. I got to list what the first term is. Okay, because again, if I didn't know the sequence or if I was just showing it to somebody else, I got to tell them what the first number is. Okay? All right. Now, hold on. Before I let you go, guys, last thing. What do you see? What in both of these things, what do they have in common? What's in both of those equations? AN, what else? Let me be, like numbers-wise, what's in both? Excuse me. Kathy. Yes. What else? That's what you're going to say. What else is in both? The first number, the first term, the negative 9, right? So the first term is in both. What else is in both? The 4, right? The plus 4, right? So both, it doesn't matter which equation you're doing, you should have the first term and the common difference in both of them. Okay? All right, that is it.